I recently purchased this NymoLabs NBS-6040 CNC router. I have not done a lot of cutting on it yet, however, so far I really do like the machine. I don't want to mark up the existing spoil board and work area that came with the machine. I do like the integrated T-track, however, I do want to put a spoil board on it. I know people have a lot of opinions as far as what a spoil board should be. I'm using what I have on hand, which are threaded inserts. I'm going to put threaded inserts into the existing work bed, secure down a spoil board, and put threaded inserts into that as well. So we'll see how it goes.
One of the first things I did was give myself a point of reference for alignment of the spoil board. I etched basically the corners into the machine bed at the limits in each corner. I found the machine limits to be 610 millimeters by 410 millimeters deep. Um, so it just will help with alignment. And then here I'm setting up for actually drilling the threaded insert holes into the machine bed. So that will hold the spoil board down to the machine. One of the primary reasons I want a spoil board, uh, rather than this integrated T-track system that NymoLabs provides, is the fact that I can't surface the whole thing. Uh, if you surface it, it'll create a kind of a grooved area that's surfaced and then non-surfaced. And if you have a piece that's larger than that area, it's not going to sit flat. So I want a spoil board that will sit on top of this. I've always used threaded inserts. I don't have a problem using them. I'm not a huge fan of double-sided tape or the tape and CA glue method. I don't find it to be quick. I find I can actually change setups pretty quickly with threaded inserts. I don't have an issue with that. Someday I may look at another integrated T-track system, but right now I have the threaded inserts. I actually ended up buying a few more just because I want some more holes, but I just find that works better. So here I already set in all the threaded inserts into the machine bed. Now I'm getting ready to drill all the holes into the spoil board. Spoil board itself is about, I think about 25 inches by 16 and a half inches. It's a little bit bigger than the cut area just because I'm working with a 1-inch surfacing bit, so I get a little bit of overhang that I can work with. One thing to note is the dust shoe, while it is effective from what I've found, it is a little finicky, I think, just getting it placed. You really have to be careful that you set it with the trim router down in the actual dust shoe just to make sure everything's aligned. If it's not aligned, you can get caught on it and it'll push it down when the trim router comes down. So just be careful with how you set that and just double check it and make sure that you got the clearance that you need. So the first thing that I do on the spoil board is drill out the hold down holes. I don't like to combine the hold down holes with the threaded insert holes into a single job. I do split those apart. Um, the holes themselves are 5/16 inch holes that align with the workbed threaded inserts that I put in previously with the 1/2 inch countersink. The countersink keeps the bolt away from the cut area and also lets me use those holes for 1/2 inch dowels that I can use as a fence. One thing I do like about CNCJS, aside from the fact that I can just run it from my tablet, is that it does provide the ability to set up some quick access buttons. I use those quite a bit because I have 9 buttons set up to take the machine to various positions on the work area. So I have 9 buttons set up to move the machine around. So basically front left, front middle, front right, center left, center middle, center right, and then back left, right, and center. Um, so it's just a quick way to move the machine around that I really do like having. So here I'm just going to drill out the threaded insert holes. I've already attached the spoil board to the machine. Initial thought on that was just that the alignment would be better. However, I actually ended up running this again and creating in the second spoil board, which I'll show a little bit later. I just didn't record it. But initial thought was just the alignment would be better. But in the end, I just drilled these holes out right after I did the hold down holes before I attached the spoil board to the machine. And then ultimately I added the threaded inserts off the machine. That way, if I bottom out any holes or any threaded inserts, I can address that easily. I think some people don't like threaded inserts just due to the time that it takes. I think cutting some slats of MDF and putting it in between T-track is much faster, but I really don't mind. And actually, I doubled the amount of threaded inserts in my second spoil board that you'll see a little bit later. I don't think it takes that long. Just grab a bit and a drill, and it doesn't take that long at all. So here I'm setting up my 1-inch surfacing bit. Like I said, I use this. I can run the board a little bit larger, about a 1/2 inch larger on each side, um, just to give me a little bit more area. Um, and you can see also I'm using those quick buttons to move the machine to a predefined area. Just moving it so I can mark up the board, just so I can identify any areas that don't get surfaced a little bit easier. So I actually will end up doing 2 passes on this just to make sure I've got all the area surfaced. My dust collection, I would just run from a shop vac that I have attached to a wireless remote, so I can stop and start it pretty easily. Um, I have it running through some PVC that runs up overhead, and then also to a couple other pieces of equipment that have blast gates attached to it. Here you can see I'm getting some dust that's coming out. I stopped the machine, and I'll adjust the dust shoe here, um, and just pause the job and try to move it down a little bit. Again, I kind of do find the dust shoe a little finicky. I may look at changing it at some point in the future. You can also see just from those pencil marks, I'm not hitting the whole spoil board. I'm getting the back half of it, but not the front half. So I could have stopped the job and just lowered the zero a little bit or increased the depth of cut. But I just let it run, and I'm just going to run it again just to get the full spoil board. So here I'm just going to run a second pass. I didn't change the depth of cut or anything like that. I just re-zeroed and run the job again. In the end, I probably should have just made the depth of cut a little bit larger just to do it in one pass, but I just ran it in 2, which worked out fine. I just missed that front right corner there.
So the spoil board's done. All the threaded inserts are in. It's been surfaced. Might look a little different than it did in the time lapse, and that's because I did go ahead and change it already. The original spoil board I had used the threaded inserts that I had on hand, and I wanted some additional inserts in there. So I changed the spacing to 55 millimeters, which works better with the underlying machine bed. And I also worked from the center out, which means that the first 2 and the last 2 rows are a little bit closer together, and that's just to work with, again, the underlying work bed. But this will work better for what I need, and it gives me several options. I can use dowels for setting up the fence. I can set up a fence using either machined fences or 3D printed. I have a couple 3D printed right now where I can set those up and set a fence so I have registration. But I can also use dowels in the spoil board hold down holes. These are 1/2 inch holes. You take 1/2 inch dowels. So I can use these and also set up registration. Put a workpiece in. So this is not going to provide any kind of top holding, but would be good in a V-car situation where you don't have a lot of upward pressure. So I can set up a fence. I could also use dowels here, but I have a couple smaller pieces of angled wood to do the hold at the top, where you can put in some wedges. And that'll hold it in place. So I put one on the right hand side as well, just to hold everything in place. So that's one option. I don't do a lot of V-carve, but that's something I can do. Let's see. So I do have 3D printed clamps as well. I also have some wood clamps. I don't use those a lot. They're kind of clunky. But, you know, you can use a wood clamp with an adjustable spacer on the bottom and set these up to hold down. But again, I do find these a little clunky. I don't like using those a lot. But I do have 3D printed clamps that I just drew up really quick in Fusion. You can find these on Thingiverse as well. Again, just an important note is when you print it kind of on its side, provides a lot more strength for the hold down. I also set this up so with some work pieces and setups that I have specific that I want to run. So I did print these clamps that can hold 2 pieces down at once. So I'd like to run something like this 2 up. So that would provide me the ability to set up 2 pieces. Where if this were a full-length piece, I could set that up there. And then I'd have my regular clamps on the bottom side. So I've always used threaded inserts from the beginning. I know a lot of people are in favor of the T-track. I just don't find it as useful, and I find I have a lot more options with the threaded inserts. I'd perhaps like a hybrid, which is kind of what, you know, NymoLabs gave us with this, but I'm not a huge fan of the threaded nuts on the T-track. It doesn't take the standard, well, I won't say standard, but I like using the 1/4-inch bolts with the hex heads, which you can't use in these. And I find that these will back out of that threaded nut a lot, which just makes it a hassle. But here, you know, I like the clamps with the threaded inserts. I can run 1 piece here, another piece here, with, you know, clamps in the back. That lets me run those 2 up. Again, this is kind of a specific setup that I planned for. So, and kind of the last hold down method that I use is I drilled a template in Luan, just a thin piece of plywood that matches up with my threaded inserts. So what that lets me do is drill through holes on my workpiece like this. So it's kind of a take on, you know, using the screws hold down method, or some people use nails. I've seen people use pin nailers. Again, I don't want to, you know, drill into this in places that I don't need to, or screw into it. But I can use this with some nylon screws. The holes will match up with my spoil board since I have that template. And then I can just screw these down. You could use metal screws or bolts. It's a little bit safer to use the nylon. You won't, if you run into one, you won't mess up your bit. I try to be as careful as I can when I'm setting up a new job, and you know, making sure that it runs as I expect, won't hit anything. So once that's down, that's going to hold pretty well. but you never know what can happen. Machine can go off in one direction and lose steps or something like that. It can happen. So I like to use the nylon bolts, so that works well for me as well. But that's pretty much my take on hold down. That's why I wanted to do the spoil board. I also usually zero from the spoil board and work my way up as far as the measurement. So when I'm setting up my jobs, I always set up from the bottom of the workpiece. Sometimes I'll surface the workpiece again. So that just, I don't like to mark up the spoil board. I got a few surfacing that I can do on the spoil board, so I have some room to work with. I will mark it up a little bit, but when I do that, it's not going to be deep, so I can surface it pretty easily and get back to this kind of state. So, but that's my take on it. I know a lot of people have their own opinion, but this works for me. I just thought I'd share. All right, thanks.